Hi again, Marcos here. I hope you don't mind me calling you Kevin or Dr. Kevin if you prefer. Just to show another experiment I made, and just taking for example one what you mentioned being called over unit view, and so I made this simple contraption. And in here with this program, it's a beautiful program called AlgoDo. I can send you more details if you want. I can control, or I can control the oh, sorry. Go back a second. I'll just fix these items here and here, so that won't happen again. I can control, I'm using this as a reference, so I can control the like a motor we have here, and I work it out that if I turn the motor off, it will find its moment of rest, and if I turn the motor back on, I work out that around 34 with a low speed with about around 35 newtons meters, the motor is capable of turning the wheel. Each individual ball has 2 kilograms in reference to an overall 26 kilogram or something of for the wheel. It's I mean for the center of the wheel. 10% on each of the 12 tooth, but that doesn't matter too much. Except for the torque of the motor, I suppose. But here, so 35 newtons is enough to turn clockwise. If I reverse the torque, is gonna do the same. If I fiddle with the force, it will come to around 32. Will not be able to produce movement. At least wasn't able last time around. And in either, I'll go back again. In either direction, so 32 in here, it should come to, yeah, eventually it almost makes, but it doesn't quite. So I worked it out, about 34 is the ideal. There is some friction in the actual system, and there is air, also a bit of air resistance. Anyway, my point is that either way, reversing or not reversing, the same amount of energy is required to produce movement. So I don't believe this could be called an over unit wheel. So that's basically my point. Oh, that's stopping here. Oh gosh, I'll move this away a bit. Yeah, that shouldn't happen. Okay, now anyway, as I said, I'm learning how to use this program. Now I want to I'll close this, I'll stop that and close and open another one, which is what I'm experimenting. As I said in the previous clip, I was having difficulties. I will not be able to replicate the atmospheric pressure. So I can play with air velocity and air speed, but only in the sense of the particles hitting items, but not necessarily the pressure of the anyway, to make the story short, I could not reproduce pressure or the lack of it. So I'm trying to make another contraption which is not as ideal, because I did want to use pressure to analyze. But here I have an interesting system where if I analyze this view, here I'll play so you can have a feel. If I can move a little bit, so this is loose, this engine here, the teeth are locked into it with this item. Those 3 items have negligible weight, and so all spinning around the same axis. This item here has 15 kilograms, this item here has 15 kilograms equivalent, and this amount of fluid has about 15 kilograms. So that's the type of arrangement. And I suppose the area here is smaller for this area, but anyway, I'm not getting to that. What I want to show is that, and I could not use the torque for the motor because with the liquid wasn't playing very well. But I will demonstrate differently that if I push the system this way, eventually the weight on the left is forcing the liquid up, and eventually the liquid goes up and it does the job. Let's see if I push the off. Yeah. So the potential energy is transferred to the liquid, and sorry for that. If I keep going again, this time I have to turn the weight over the center, and now I can almost let it go, but I have to wait a bit more. But yeah, around here I've done a few times. Just wait a little bit. Yeah, not quite. Yeah, around here. So that finishes off. So anyway, you got the gist of it. What I'm experimenting here is always the weight more producing an effort, or trying to push the fluids up and to the left. So I call this more like an over unit wheel, and I just want to show one more demonstration. I'll just turn this off for a sec. I'll stop. This rests at more or less this point here. I have a little reference there, and I'm gonna bring one of those weights. These are very heavy balls, and I'll put here. I'll turn this off for a sec, and I'll take one more. So they are very heavy. I think 150 kilograms. But was the minimum I needed to make it amount of energy to make the thing spin more than, or change the state, so it doesn't come back to the same. The reference doesn't stay there. So if I play that, yeah. So it manages to produce an outer state of. It managed to spin the wheel. If I go back, and if I do again, it will happen again. If I move this to here, I have to, and I let it go. The reference goes back in, not quite make. I have to increase to twice the amount of weight, and I try to make symmetrical. I've done all sorts of things, but it requires more than twice the amount of energy to make this state alter, to make a cycle or some sort of cycle. So I thought that was an interesting experiment, which demonstrates that it is a true what you call the off-centered or out of balance. I don't remember what it's called. Now, one thing that you mentioned about gravitational field has no cow. I don't quite understand that, and I feel like this is an example that does causes the cow, if that's what I understand, in the sense that the potential energy keeps moving sideways without any loss. So that's my understanding. Anyway, I'll write a little bit more, and hopefully you survive this clip. Thank you very much.